Welcome back, guys and girls. So what I'm going to be tearing into is this little battery powered work light that I picked up at Harbor Freight. It's a Luminar Work 10 LED SMD type LED rechargeable work light with mag base. According to this, it's got a 7.2 volt 600 milliamp NiHm, which is nickel metal hydride battery pack. So I'm going to open this up and see what's inside of it, what the build quality is, and I'm going to try and see if I can get this upgraded to run on lithium ion batteries. I have a bunch of 18650s, so we'll see if we can't convert this over to lithium to get a little better battery life. This thing overall, it does put out a good amount of light. It's really lightweight, and the mag base is really nice for sticking it on things when you're trying to see stuff in dark locations. However, the battery life in this thing is horrendous. It takes about 4 hours to charge, and you get about 15 minutes of usable light on the high setting and probably about 20 minutes on the low setting. And for the amount of LEDs that are in here, we should be getting much better battery life. I would like to see this thing run probably at least an hour on a single charge, if not more. But we're going to look and see if we can potentially put replaceable 18650s in here so that we can swap them out if we need to. If we can't make them removable, then we'll create an 18650 battery pack if it's possible, adding charging circuit, and see where we get from that. Plus, I kind of want to try and get rid of this dingle ball end down here. It's not very ergonomic. It kind of gets in the way and it gets bumped on stuff. So I'm going to see if this can be removed to where we just have this slim handle and the batteries will fit in this handle. So let's get torn into it and see what it looks like. So it's just got 4 screws down here at the bottom. Let me grab a screwdriver. There we go. So here's what's in the base of it. There's no battery pack in here, so the battery pack must be up here in the handle. The only thing it's got is this little 3-position switch, off, low, and high, and then the charging port. So we should definitely be able to get rid of this flared end back down here. Then we'll have to find how to relocate that magnet so that we can still maintain the magnetic function of it. It's got 2 screws, looks like holds the base on. Try and get these switches out. So it looks like they stuffed a pretty good sized battery pack in here. It's a very tight fit. Not sure if we're going to be able to get that out. It looks like they put the battery pack in and then sonic welded this red ring on here. And the battery pack sits, well, it's kind of hard to see, but the battery pack sits under the lip of this little red ring. Okay. Let me work on this a little bit and I'll see if I can't get this out. Be right back. Okay, so that took longer than expected. So what I had to do, I had to get my Dremel with an abrasion wheel and carve out all that material that was into that ring that's left over from this red portion. And I had to do it kind of around the nickel metal hydride battery pack that was in there. And you can see where it was catching on that lip, where it kind of tore the jacket a little bit. But I was able to get it out, and then I had to grind it further to make it completely smooth on the inside. See if I can get that to show up on the camera. There we go. Now I'm going to go back in there with some sandpaper before I put the batteries in, but I wanted to grind all that out to see what kind of space I'm working with inside this handle. And so I know I want to go lithium ion just because they can deliver more power for a longer period of time, and their recharge cycle is a lot shorter than nickel metal hydride or nickel cadmium, which are your other two battery options. Me as well, I also have a crap ton of 18650s, as well as these little silver packs, the Lipo battery packs, from 4.1 volt all the way up to about 36 volt, 38 volt. And one thing that a lot of people may not know that I'll probably cover in a different video are you can scavenge 18650 cells out of derelict batteries for laptops. I had a bunch of Dell laptops that I did computer repair on, and the laptops were gone or outdated, got trashed, whatever happened to them. But I kept the battery packs because you never know when you need them. An interesting fact about laptop battery packs, like this Dell one, for example, and this one's fairly old, so it can be had for dirt cheap. A lot of the times, this one has six cells in it, I believe, 3 on each side. A lot of the times what happens is only one cell goes bad, and that will show up on the laptop as being a dead battery or defective battery, and it'll tell you to replace it. So a lot of times you can open these cases up, and if it may have 1 or 2 bad cells, you end up with 5 or 6 good cells. The one thing to note when you take out 18650 batteries out of laptop battery packs are they're not designed for high current applications. If you have little projects that kind of draw small amounts of power over a long period of time, they're great for that. If you have something that needs, like if you're into vaping or anything like that, you would not want to use these cells, not only because these do not have built-in protection, like the ones that you use for vaping and other high energy applications, but they're also not designed to be discharged at extremely high rate. A lot of these laptop batteries are only designed to be discharged at a maximum of 2C, and some of them it's even pushing that. So I have some Panasonic cells here. If I'm not mistaken, most of the Dell battery packs use Sony cells, which are these green sleeve cells, and most of the HP laptop battery packs have Panasonic cells. And so they're very high quality cells. They're just not designed for high energy applications. One thing you will need to do if you go to use 18650s that were scavenged from a laptop battery pack is you'll need to put some type of button top on top of the battery to be able to use it in these little battery carriers. So what I do, I just take my soldering iron turned it up very hot because you don't want to dwell on this for a long period of time with a lot of heat, and just dab a little bit of solder to get you a nice little button similar to like a AA or AAA battery, to where it's got a section that protrudes on the positive terminal above the sleeve, and that way you can put it in these battery carriers. So battery carriers, we have a couple different choices. These are some surface mount ones that you can get for dirt cheap. These hold 18650s, and they have tabs on the back to where you can solder these through a motherboard or some kind of other PCB and surface mount 18650s. These type here are more universal. They're just spring loaded. They look a lot like they would for AA and AAA battery packs that you'd use for most of your projects. And they've got a screw hole in the center for you to put a screw, your negative and positive terminals coming out each side. And then you have the double carriers like these. They also make quadruple and 8 battery carriers. And this would be the desired application, because for this, since we need at least 7.2 volts, which is what the original battery pack was, we need two 18650s in series to be able to get that kind of voltage. We'll actually end up with about 8.2 nominal with two 18650s. But this carrier is too wide to fit in the handle. So what I'm going to use are these more generic ones, put them back to back, and they will slide relatively well into the base of the handle when the batteries are inserted. So we got our battery carriers, we have our 18650s. Another thing that we're going to need are 18650 chargers. Because this light used nickel metal hydride batteries, these have a much different chemistry than Lipos do, and so their charging requirements are a lot different. These want a very low current for a very long period of time. I think the recharge cycle on this is between 6 to 8 hours at about 1/4 of an amp, about 250 milliamps, I think is what the charger's rated at. Lipo batteries, when you're talking about 18650s, these vary widely in what their charge cycle is, so please refer to the technical documentation for your specific cells that you're using. These Panasonics here, according to the data sheet, they are 2250 milliamp, and they require charging of 4.2 volts at 1.5 amp for 2 hours. So what that's going to allow us to do is to recharge this light within an hour and a half, 2 hours, and maybe less if you use it for a shorter period of time, versus the 6 to 8 hours with the battery pack that was in it previously. Also, this battery pack that was in it was only a 600 milliamp battery pack. So this one cell has little over 4 times the power of what this giant battery pack does. So when we put two 18650s together, and we're putting them in series to get additional voltage, so we're not picking up any amperage, but we still have 2250 milliamps out of these two batteries at about 8.2 volts nominal versus 7.2 volts, which would be about 7 volts nominal, and 600 milliamps out of this nickel metal hydride pack. So we're getting much longer run time, a little bit higher starting voltage, which will get us a little additional run time because it won't start dropping amperage as quickly. The voltage needs to drop down first. So I got these little single channel 18650 chargers. These particular ones I picked up on eBay. I think I paid about $10 for 5 of them. They have micro USB in, so you can charge this off of a phone charger, which makes it great for any of your little projects that you need to power with 18650s. It also has the terminals negative and positive up top here next to the USB port for power coming in if you don't have USB or don't want to use USB. And then it's got 4 terminals down here at the bottom. 2 are for the battery input and 2 are for the power output to the device that you're powering. So these are great because it's a dual purpose board. The top half is the charging circuit, the bottom half is the protection circuit. So this will actually cut the battery voltage or cut the battery out when your device or when your batteries get too low for your device to be powered safely. One thing about LiPo batteries, you have to keep the voltage up. You don't want to discharge them too far because they have a tendency to either overheat internally, and then you get thermal runaway and the battery melts down and explodes. Or more likely, the cell will become unrecoverable and you can't charge it, and then you need to dispose of it or recycle it properly. So this little board is going to take care of both of those for us. It's going to handle our charging, and it's going to handle our protection for low voltage cutout, as well as over amperage. This little board here is rated at 1 amp per board. We're going to use 2 of these boards because they're single channel, and that fits in perfectly for what our batteries can be discharged at, which is about 1.5 amps. So our batteries will be higher capability than this charging board will put out. But this little LED strip here is probably only going to draw about 3/4, maybe 1/2 amp, somewhere in there at max setting. And that's probably giving it credit. It probably draws a lot less than that. So there's our charging circuits. What I had to do to get the battery pack out is I had to cut the charge terminal and the switch that was in the base of this handle, this big dingle end here. I had to cut the wires on it to be able to get the battery pack out and to get my Dremel in there to shave that material out to get the battery pack out. What I like to do if I have to cut wires for anything is I cut them with just a little bit of the jacket left on it, so that I know when I go to reassemble it or put this on something else, or reuse parts, I know exactly what wire goes where. So like this is our selector switch off 1 and 2, so we know our red is our incoming power for the battery, 1 is our green, and 2 is our blue. So on our cables here from the LED board, we know exactly what wires go to what. And then also on the charging plug, it had 2 blacks and a white going to the outside terminal, and it had yellow going to the input terminal. So we know our yellow on the LED board is our power input from the charger, and then we know our blue wire is going to be our high power setting for our LEDs. I don't know if I'm going to use the green. I don't know if I'm going to put this switch back in here or not. I might. I got to see how much room I have left. So those are all of our parts. Give me a couple minutes. Let me get everything kind of put together, and I'll be right back. Okay, so we got our LED board out, and I was just kind of looking over it. It is, they've done a really good job. Like, I'm actually impressed at the kind of level of quality that's here. The one thing I don't like is this kind of bodged in transistor right here. It looks like somebody shaved the board. There may have been a short or something there, and that was a kind of last minute fix, which happens a lot of the times in these kind of quick run, fast turnaround type projects. They produce just a crap ton of them, and then notice that there's a problem in the long-term R&D testing. So they do these little bodge fixes before it leaves the factory. But overall, very nice. It's got a layer of conformal coating. Looks like most or all of the components are nice and squarely on the solder pads. A lot of times with cheap manufacturing, if you look at all the SMT parts, surface mount parts, they'll all be kind of cockeyed and crooked, and you'll have a bunch of cold solder joints. I've only seen one cold solder joint on this board, and it's right there on that yellow wire. But everything else looks really good. It's not got a nice even conformal coating on it, which kind of helps protect everything from getting oxidized and from minor water splashes. So a whole bunch of wires coming off of it. I have my battery pack put together. This is not the battery pack that I'm going to use. I already have the 2 individual battery packs kind of shoehorned in there. I'll get a better light in there here in just a second. But I want to test to make sure that we have our wiring correct before we start hooking everything up. So I got 2 18650s in series. I should have about 8.4 volts coming out of here. So we're going to take our black wire from our LED board and hook it up to our black wire from our battery pack. And then, as we know from our switch, we know the center pin is positive, so positive is red. And the number 2 position, which is the high position, is blue. The number 1 position is green, so that's low power. So we'll get our green wire and attach it to our battery pack. Oh, I forgot. On the power lead, the power lug, it's got 2 black wires and a white wire that was connected to the outside pin. So the white wire also needs to be grounded. We'll go ahead and twist that together, and then we'll grab our green wire, which should be low power. That's high power. So all the LEDs light up, and then if we grab our other one, which is the blue wire, that's going to be our low power. And then only half of the LEDs light up. So that would be if you don't need as much light, but you need longer battery life, you put it in low, which I never do. I always turn it on high. But we know our connections work now. One other interesting thing that I found, or that I was looking through the wiring with, is they actually went as far as to put a thermocouple in here. So it's got a little bead thermistor, and that was crammed into the battery pack, the nickel metal hydride battery pack. Because this has a built-in onboard charger, the yellow wire is a positive wire and the black wire is the negative. That's input from the plug, from the little wall wart. And then it's got a built-in charge controller, so this regulates the power going to that. That charging circuit that's in here is designed for nickel metal hydride, and it also works for nickel cadmium, but it won't work for lithium ion. Lithium ion uses a different type of charger, which are what these little boards here are. And we'll get those mounted here in just a minute. But we're going to cut this yellow wire, we're going to abandon the onboard charger, and then we're going to mount our Lipo chargers, our 2 Lipo chargers right here on the back side of this PCB, because when it's inserted into the tube, it's got this sticker on the back side that hides all the resistors and everything. So it's going to hide our charging boards as well, and also hide this all this circuitry down here. So there's a couple wires we're going to remove. Let me get my charging boards mounted on here, get a couple things soldered, and I'll be right back. Okay, so got everything put into place, got everything soldered in. So what I did, I took my Dremel and I cut me a little notch out of this red ring to mount the existing switch that came with this light. And then I took a 5/8 drill bit, drilled the hole, and put my plug in. And then I got everything just kind of hot glued in here. This isn't a high impact application, so I didn't need to put any screws or anything in it. Hot glue will work for insulation to keep everything electrically insulated. So I have my 18650 chargers hot glued on the back of the PCB, and the LEDs are on the opposing side, so that when it's in the sleeve, you won't see any of the electronics behind it, and I can hide all these wires back behind it too. Now I could have shortened all these wires up, but I wanted to keep them long for ease of assembly, and then if I have to take this apart later. So each of these 18650 chargers, they have the power inputs for the negative and positive on each side of the USB port brought down directly to the charging port. So the center pin is positive, the outer ring is negative, so it goes straight from this charging port to the power inputs on both boards. The battery output on this board, they split off. This is one battery and this is the second battery, so that each battery can be charged independently, and each battery has a protection circuit for under voltage and over current. So that makes sure that each battery is protected like it should be, since these are non-protected 18650s. And then the power output for each of these boards is a negative and positive for each one. I have the negative of this board jump it over to the positive of this board, and then I have the negative of, or the positive, the negative of this board, sorry, tied into the ground for the PCB. The white wire and the black wire going to the LED PCB. And then I have the positive wire on the second board going to the center pin of my switch, and that will give the 8.2 volts from the batteries out of the regulator, out of the chargers, directly to the center pin of the switch. And then the green wire and blue wire are soldered to each end of this switch, so that when you turn it one way, to the 1, half the LEDs light up, center is off, and 2, all of them are on. So now this is, I think, a great improvement over what it was. I've done away with that big end down here. It's got a much more improved battery life on it now. It's got about 2250 milliamps at 8.4 volts versus the 7.2 volts at 600 milliamps that came with it. So we've almost quadrupled the total capacity of this unit and reduced its size considerably because it doesn't have that big end down here. So I took the magnet. This is actually the metal base and magnet that came out of the bottom cap, and it was just screwed in here. I simply unscrewed it, pried it out, and then ran the screw into the plastic housing on the bottom of this, and I had just enough room to where it cleared my 18650s in here. So I have my temperature probe that's still intact, and because we're running power through this board, this should be able to interrupt the charging cycle if the batteries get too warm. So we're going to feed that down in there, and we're just going to tuck it up next to the batteries. We're going to take our casing. Oh, also too, because I put the switch and the charging port into this red ring, typically this acrylic tube would go all the way down to the bottom of this red ring. So I had to take my Dremel and I had to notch out a small section of it. There and there. So that one is for the switch, that one is for the power connector. We'll take our LCD PCB, we're going to take all of our wires and just fold them over. Then we're going to tuck them into the acrylic tube as we insert the board. Do one more sanity check before we push everything together. And then I did have to open this up a little bit, the inside of this red ring, to get my battery packs to slide in there. So what I'm going to do, as soon as I get all the wires to clear everything, just going to hot glue this in here, wait for that to cool so that it's sealed. Because we put some extra hardware in there, the switch and the charging port, this tube doesn't sit down all the way, so it's not a tight fit like it was originally. And there we go. So it's substantially smaller. It's still magnetic. so we can stick it on anything we want. I'm trying to find something magnetic. And it's a lot smaller, so it gets into tight spaces. We still have the hookup at the top. We still retained our multi-position LED, and we still retained where we can use the factory charger. So you take the charger, you plug it into the charging port, and it charges, and then the chargers automatically turn off when it's fully charged. But the greatest thing is that we've increased not only the brightness a little bit because we've added some additional voltage, about 1.5 volts, but we've almost quadrupled our total runtime of this thing while not getting any more bulk to it. We actually reduced the size of it. So that was my fun little project. It took me about an hour or so, and that's just parts I had laying around. If you got any questions, post them below. If you like this video or have any comments for them or suggestions for them, put that below as well. If you enjoyed this video, please rate, comment, subscribe. We'll see you next time.